For over a century now, a single powerful equation has dictated how massive structures warp the fabric of space. We treat this formula as a foundational law, a rulebook handed down through the Hilbert-Einstein action to explain gravity. But treating the equation as a given starting point masks a logical loop hiding at the base of modern physics. We use the distribution of matter to explain why space curves. At the exact same time, we rely on the curvature of space to explain how matter conserves its energy. The underlying math works perfectly in everyday practice, yet because the logic loops back on itself, it stops short of explaining why the universe is forced to take this specific shape at all. The observer-dependent theory of everything approaches gravity from a different starting point. It requires all physics to emerge directly from the act of observation itself. Under this framework, the Einstein equation is stripped of its status as an assumed law. Instead, it is tested as a strict mathematical necessity for keeping the cosmos stable. This stability requires self-consistency. A universe must continuously balance its spatial geometry and its matter to avoid mathematical collapse. To prove this, we need a mechanism that forces space and matter to agree, without leaning on the historical, circular assumptions of classical relativity. This mathematical proof identifies the Einstein equation as an absolutely inevitable consequence of a universe maintaining its own existence. That mechanism is called the phi map. Think of it as the mathematical engine driving the universe's self-consistency. The forward map calculates the exact matter required for a specific geometry. Then the inverse map pushes back, updating the curvature. This constant negotiation shrinks their differences with every cycle until the system hits a fixed point, locking into perfect stability. When we translate that final locked state back into physical terms, we get the exact tensor structure of the Einstein field equation. Space and matter engage in infinite geometric negotiations. The equation we have used for a century is simply the final, stable agreement they reach. Showing a mathematical feedback loop is one thing, but we have to prove this process avoids the circular logic of traditional physics. To do that, the theory runs an anti-circularity audit. We trace two entirely independent mathematical paths to see if they reach the same destination. Path 1 is purely geometric. It evaluates the kinematic smoothness of spacetime without ever looking at the matter inside it. Path 2 is entirely dynamical. It looks solely at the symmetry of the observer's action, utilizing Noether's theorem to track energy conservation without assuming any pre-existing geometry. The ultimate stress test applied these paths to the vacuum of a Schwarzschild black hole. Calculated independently to 50 digits of precision, both paths converge to the exact same numerical result. Two distinct logical foundations arrive at the same physical reality, validating the self-consistency of gravity as a foundational property of the universe. With the loop proven in a stable universe, we must examine what happens when that mathematical harmony is pushed to the extreme boundary. This boundary is mapped by the ODTOE singularity theorem, which calculates the exact moment the underlying observer structure begins to break down. Historically, the mathematics of gravitational collapse and black hole singularities were defined by the classical Hawking-Penrose theorems. Classical relativity defines a singularity as a point of infinite density. This framework defines it as the complete failure of the feedback loop. The system reaches an ontological collapse condition. The mathematical value of observation itself drops toward zero. When that happens, the phi C map cannot complete its cycle. The forward and inverse iterations fatally terminate, leaving the universe unable to compute its next state. The iteration terminates at the point where the universe runs out of future. It marks the exact boundary where reality loses the ability to self-correct. Space-time and gravity exist as the literal, required shape the universe must take to remain observed, consistent, and real.